Okay, here's the exponentials question on this particular paper, and it's about hamsters. Fairly gentle start. We're given the formula for x in terms of t, and we've got to find the length, which is x, of the hamster when it is born, and of course that's a value of t that it's given you. T is the number of days after its birth. So there's a t value to shove in dotty 1, and then we've got another t value to shove in dotty 2, and in each case you're going to put that in the formula and get what x equals. 3 marks so far, nothing hard has happened. Then we've got to show the time taken for a hamster to grow to 10 centimetres in length. So now x equals 10, and we've got to find the value of t. So you substitute in x is 10, and you rearrange, and to make the e go away when you're ready to, you use a log. So none of that's hard, but you're quite likely to have just before the end minus 14t equals a log of a fraction. And then, minus t over 14, that should be. Minus t over 14 is log of a fraction. And then you're going to think, okay, so t will be minus 14 times that log I've got. And you'll wonder what's happened to the minus sign. Now, what you've got to remember there is your rules of logs. Okay, a minus sign times a log, forgetting about the 14 for now, minus log of something, called it x, is just plain old log of something. You need to think this is minus 1 times log of something, so it's log of x, and then if you remember your rules of logs, is x to the power of minus 1. In other words, it's log of the reciprocal of x. So if you've got an expression like this, then you're not wrong. You've just got one more step to do where you have to convert a negative log into log of the reciprocal. Then moving on to C, show that dx by dt equals this. Well, this can be very confusing, but don't let it confuse you. Start with this as your starting point. Dx by dt, we know what x is in terms of t, so you can differentiate that. You get dx by dt equals, you merrily differentiate, and it comes out in terms of t's. What's confusing is that this answer here turns out to be in terms of x's. So it's one of those situations where the end point, the show that bit, is confusing you if you let it put you off. Differentiate what you see, and then you can put this at the bottom of your page, and you can work in both directions. Dx by dt, start with what that is, but if you substitute the x into here, 15 minus this x, well, the 15s are going to cancel, the minus and the minus are going to cancel, so 15 minus x is just going to be this term here. And when you multiply that by 1 over 14 and compare with what you got for dx by dt, you'll notice that it's not a million miles away after all. So start by differentiating this normally, but then feel free to put this at the bottom of your page and work back up to it, and you should be able to make the two things join up in the middle. Then finally, and it's another re-entry point, find the rate of growth of the hamster in centimetres per day when its length is 8 centimetres. So the rate of growth, that's just code for d something by dt, in fact dx by dt, and we're given that x is 8 centimetres, so all you have to do for this 1 mark is substitute your x equals 8 into that expression, get it as a decimal in centimetres per day, and that's an easy mark at the end of the question.